Hello, you guys. Welcome to chapter 5. We are starting our new chapter today about factors, multiples, and something called divisibility rules. We are actually going to kind of go out of order. We're starting with lesson 2. And so I need you guys to go ahead and grab your pencil, your math journal, and your multiplication chart. And we are going to be on page 286 today. All right, once you have your journal on page 286, we are looking at the top box first. We are going to be first talking about something called divisibility. And it kind of sounds like the word division, but divisibility is just kind of talking about if a number is able to be divided by another without having a remainder. So for example, if I asked you if the number 8 is divisible by 2, the answer would be yes, because 8 divided by 2 is 4, and there's not a remainder. But if I asked you, is 8 divisible by 3, the answer would be no, because 8 divided by 3, if you did that, you'd get a remainder. So there would be some left over. So when we're talking about divisibility, we're just thinking, can the number be divided without a remainder? So on page 286, the official definition says, a number is divisible by another number if the whole number quotient, which means the answer, is a counting number, and the remainder is 0. A counting number is just regular numbers, 1, 2, 3, 4, 5, 6, 7, 8, whatever. And so really the main important part is that the remainder is 0. And so to find out if a number is divisible by another, there are lots of different ways to think about it. One, you hopefully have all your math facts memorized, so that could be one easy way. So just because you know the factors of 8, you know your basic math facts, you know 1 times 8 is 8, you know 2 times 4 is 8, those will tell you what numbers 8 can be divided by. So knowing your basic math facts is one way. Another way is actually doing division. So if I asked you, for example, this question says, is 6 a factor of 72? They're basically asking you, is 72 divisible by 6? So you could also do long division and really work out 72 divided by 6 and see if you get a remainder. However, today we're going to learn a shortcut using these things called divisibility rules. So this little green chart on page 286 tells you some different shortcuts. They're kind of like little cheats so that you can tell if a number is divisible by another without dividing. And so this is how this works. So it says if the number is even, the first one, the number is even, it can be divided by 2 evenly. So if you have any even number, it can always be divided by 2. And then we'll talk about the other ones. And so this is just a shortcut, another way to think about divisibility. So this first example says, again, is 6 a factor of 72? So we're trying to decide if 72 can be divided by 6 without a remainder. So it says test for divisibility. So look over at your chart, the green chart. The rule for 6 says the number is even and divisible by 3. So if 72 is even and can also be divided by 3, then automatically, without even testing it, it can be divided by 6. That's what this rule says. So first let's check, is the number even? Since it ends in a 2, I know that it's an even number. Number even numbers 2, 4, 6, 8, 10. So yes, 72 is even. Okay, and then it says the number is even and divisible by 3. So can 72 be divided by 3? You could divide it if you want by 3. You could do long division, or you can look at your chart again and look at the rule for 3. It says the sum of the digits is divisible by 3. Remember that sum means to add. So if you add the digits in 72, which means you add the 7 and the 2, which is equal to 9, it says, is that divisible by 3? Is this 9, 7 plus 2 equals 9, divisible by 3? Can 9 be divided by 3? Yes, because I know that 9 divided by 3 is 3. So that means, since it was even and it can be divided by 3, that 72 is also divisible by 6. So yes, 6 is a factor of 72. And so today, we're just going to be practicing using these rules to hopefully speed up finding factors of a number so that you don't have to spend as much time doing long division. If I were you, I would mark this page somehow because you're really going to want to keep this list of divisibility rules. I would either fold the corner of this page over so you can flip back to it quickly, put a post-it note on the corner where you can find it really fast, or you could put a paper clip or something, but somehow mark page 286 because this chart is going to help you for the rest of this chapter, actually. All right, when you're ready, we're actually going to jump. We're going to come back to the try it question later, and we're going to actually look at page 287 next. Okay, so we are on page 287, the share and show section. I copied my green rules chart so that it was on this page. So you guys are just going to have to look back at the last page to help you with the rules. But number 1 says, is 4 a factor of 28? Draw a model to help. So first of all, remember what a factor is. A factor is just a number that's multiplied by another to get an answer. So for example, I'll write an example up here. 2 and 4. 2 and 4 are both factors of 8 because when multiplied they equal 8. So they're asking you, is 4 a factor of 28? Essentially, is 4 divisible by, or is 28 divisible by 4? If you look at your chart though, it goes 2, 3, 5. There's not a rule for 4. And so in this case, you either need to know your basic fact or you need to be able to divide because there isn't a shortcut for the number 4. So they're asking you, is 4 a factor of 28? They gave you a model to kind of help you. It says, can you make a rectangle with 28 squares in 4 equal rows? If you think about it, if you did 4 equal rows, how many would you need across to equal 28? If you know your basic fact, that 4 times 7 is 28, you would know that 4 is a factor of 28. So again, factors are just the numbers that are being multiplied together to equal the answer for the product. And so 4 is a factor. So for 4, since there wasn't a shortcut, I just used my basic facts. For the next few, number 2, 3, 4, and 5, the directions say, is 5 a factor of the number? Right, yes or no? So on this one, you're only looking at the rule for 5. The rule for 5 says the last digit is 0 or 5. So on number 2, the number is 27. Is the last digit in the number 27 a 0 or a 5? No, it's a 7. So then automatically, without even thinking about my basic facts, I know that 27 is not divisible by 5. Okay, but on number 3, 30 ends with a 0. So yes, it can be divided by 5 evenly. And you can also know 6 times 5 is 30. Number 4, 36, is the last digit a 0 or a 5? No, it's a 6. And then number 5, 53, is the last digit a 0 or a 5? No. Okay, so we're just using our rule again to kind of speed things up. So go down to the next section now. Is 9 a factor of the number, right? Yes or no? So now we're looking for the 9s. Look at your rule for 9. It says the sum of the digits is divisible by 9. So that means if you add up the two digits, like on number 6, 54, if you were to add up 5 plus 4, sum means add. 5 plus 4 is 9. Is the answer 9 divisible by 9? Can 9 be divided by 9? Yes, it's 1. So then I know that 54 is divisible by 9. Or you might know that 54 divided by 9 is 6. So there's another way if you just knew that fact. Number 7, 63. If you add up the digits, 6 plus 3, you get 9. Again, can 9 be divided by 9? Yes. Or you might know the fact that 9 times 7 is 63. Number 8, 6, add up the digits, 6 plus 7, which is 13. Can 13 be divided by 9? No, because nothing times 9 will give me 13. So that means that 67 cannot be divided by 9. Number 9, if you add 9 plus 3, you get 12. And then use your rule. The sum of the digits is divisible by 9. Can 12 be divided by 9? No, because 9 times nothing would give me 12. Okay, so again, just use your rules. And then come down to 10 and 11. These say list all the factor pairs on the table. So these are kind of nice because they tell you exactly how many you're looking for. Use your rules again, or you might just have some of these memorized because the factors of 24, for example, a lot of them are our basic math facts that we've already memorized. So you're looking for two numbers that go on the chart that are going to equal 24. These will all equal 24, and they are telling you that there are 4 pairs of numbers that equal 24. It's your job now to find them. I will tell you that when you have these tables, one of the answers is always going to be 1, because remember that 1 times anything is just itself. So in this case, 1 times 24 will give you 24. So the factors are 1 and 24. Okay, so then use your other facts. You might be able to fill in the table by yourself just because you have your facts memorized. If you don't, though, you can go back to your divisibility rules. Let me go back up and look. And use the rules to figure out what can be, or what 24 can be divided by. So I would just go down the list. We already figured out 1. But now, can 24 be divided by 2? Some of you might know that, or if you don't, look at the rules. It says, in order for the number to be divisible by 2, the number has to be even. So is 24 even? Yes, because it ends with a 4. So that means that 2 times something will give me 24. If you know what that is right away, go ahead and fill that in. If you don't, off to the side, you'll have to actually do division and figure out 24 divided by 2 is what? So 2 divided by 2 is 1. Bring down the 4. 4 divided by 2 is 2. So that tells me that 2 times Uh-oh, my pen stopped working. Oh no. 2 times 12 is 24. So the next factors are 2 and 12. Okay, so then you might remember some more basic facts. If not, I've tried 1, I've tried 2. Look at your rules again. Now try 3. It says the sum of the digits is divisible by 3. So if you check, if you were to add up the digits in 24, 2 plus 4, which is equal to 6, can that be divided by 3? Can 6 be divided by 3? The answer is yes. So that means that 24 can be divided by 3. So now think, 3 times what is 24? You should get 8. So the next factors are 3 and 8. And there's one more pair left. You might know it already. If not, you could go back and check your list. There's not a rule for 4, so I'm going to skip 4 for now. 5, the last digit is 0 or 5. 24 does not end in a 0 or a 5, so I know that 5 won't work. But for 6, it says the number is even. We already said 24 is even. And it's divisible by 3. And since we already figured out that 3 times 8 is 24, I know that 24 is divisible by 3. So the last factor pair is 6 times something equals 24. And if you already know it, excellent. But it is 4. And so the last factors are 4 and 6. And so you maybe could have figured this entire thing out without using any of the divisibility rules, which is awesome. The divisibility rules are just a really big help if maybe you don't have all your facts memorized. We're going to try 2 more today. Number 11, we're going to do the factors of 39. So we're going to do the same thing we did for 10, except now we're talking about the number 39. So remember what I said earlier, automatically I know that 1 is a factor because anything times 1 is just itself. So 1 and 39, 1 times 39 equals 39. So the first factor pair is 1 and 39. And then if you're feeling pretty confident about this, why don't you pause here and see if you can figure out there's only one more factor pair for 39. And then when you're done, check back in and see if you found it. If not, that's okay. Try to think of some basic facts that could equal 39. If you can't think of any, that's okay. Go back to the chart and start with, we did 1, now do 2. It says the number is even, so think, is 39 even? No, it's an odd number, so I know that 2 will not work. Okay, so go to 3. It says the sum of the digits is divisible by 3. So if you take the digits 3 and 9 to make 39 and you add them, 3 plus 9 is 12. The sum is 12. Can 12 be divided by 3? Yes, because 3 times 4 is 12. So that means that 39 is divisible by 3. So that means that the next factor pair has a 3 in it. Now, if you can do that in your head, figure out 3 times what gives me 39. Great. If not, go off to the side and do some long division. Goes in 1 time. Bring down the 9. 9 divided by 3 is 13. 0 left over, so I know that 3 times 13 is 39. So the other factor pair is 3 and 13. All right, let's try one more. Turn the page and go to page 288. And we're going to try number 14. This one, again, I just moved the green table over so that you guys could see it on this page. If obviously your book doesn't have it on this page, so you'll just have to flip back. But number 14, this kind of, you don't really have to do any math, technically. You just have to use some common sense here. If you want to go ahead and try it on your own, that's fabulous. Pause the video, check back in when you're done. Number 14, though, says, Dirk bought a set of stamps. The number of stamps in the set he bought is divisible by 2, 3, 5, 6, and 9. Which set is it? So if you think, over on the right is the list of options here. It says that the number of stamps he bought is divisible by all 5 of those numbers. So you can start eliminating them just based on the rules that you know. So when it says it's divisible by 2, the rule for 2 is that the number has to be even. So right away, you can cross off any numbers that are not even. So Germany ends in a 0, it's even. Sweden ends in an 8, so it's even. Japan and Canada, though, are odd numbers. So I know right away, just by using logic, that these two cannot be the answer. Okay. So then you can think about 3. Which of these is divisible by 3? It says the sum of the digits is divisible by 3, to be divisible by 3. So if you have Germany, write G for Germany and S for Sweden. If you add up the digits, 9 plus 0, just 9. Is that divisible by 3? 9 divisible by 3? Yes. So that would work. And then Sweden, 7 plus 8 is 15. Can 15 be divided by 3? Yes. So they're both divisible by 3. So that didn't really work to knock one out. So now move on to 5. The rule for 5 says the last digit is 0 or 5. Looking at my 2 numbers left, I know that Sweden cannot be divided by 5 because it ends with an 8. So the only answer that makes sense logically left is Germany. And if you, for some reason, didn't want to use your rules, another way to find divisibility is doing long division for each one of those. And so I hope that you see kind of that the divisibility rule might save you some time. I know that they can be maybe a little confusing at first, so if you have any questions, please let me know. But we will keep working on this tomorrow. All right, see you guys later.